we're going to do some demonstrations using liquid nitrogen. Of course, we're familiar with nitrogen because nitrogen is in the air that we breathe. Almost 80% of the air that we breathe is made of nitrogen. But when nitrogen is cooled and compressed to temperatures of around 200 degrees below 0 Celsius, it changes from a gas that we're breathing to a liquid. And it looks a little like boiling water. We're going to pour up some liquid nitrogen into this container so that you can see what we're talking about. But before we do that, we have to put our safety measures in effect. We put on our goggles to protect our eyes, and we have gloves to protect our hands. The liquid nitrogen is in an insulated flask here that keeps it a certain temperature, and we're going to pour the liquid nitrogen into the container. Looks a lot like boiling water. But as you can notice, the steam goes down. It doesn't go up like boiling water steam because the liquid nitrogen is heavier than the air that's in this room. Okay, that should be enough. We're going to do a couple of demonstrations with the nitrogen, well, maybe just a little more. Now, we have a couple of carnations here. Very nice, soft carnations, very fresh. We just stopped by the florist on our way here, and they're very soft. But the property of this carnation would change very rapidly if it's exposed to the liquid nitrogen because the liquid nitrogen is a very, very low temperature. So let's stick the carnation in there for about 5 seconds or so, and it changes from a very, very soft flower to something that's very dry and very brittle. So you can see the liquid nitrogen is very, very cold. So we're going to do another demonstration with the liquid nitrogen, and that involves these balls that we have here. Now, we're going to bounce a couple of them to show that these balls are elastic. That's why they have the tendency to bounce. But after they're exposed to the liquid nitrogen, we'll let that one stand there. And it only has to stand for about 15 or 20 seconds or so. And let's see if we can't. Now, you noticed the sound before? You notice the sound now. The ball has frozen. The molecules have stopped moving around so much, and it's lost its elasticity. But the good thing about the rubber, unlike the flour, is that when the ball is exposed back to room temperature after a certain amount of time, it will thaw out, gain its elasticity, and will be just as good as new. Of course, the petals of the flower will die because after they have been exposed to the liquid nitrogen, they would no longer be able to go back to being that soft aroma-filled carnation.